Hello everyone, I am Shashank Bagda from semester 5 ICT, and today I am going to explain some gate based MCQs of design and analysis of algorithm subject. So first of all, let's understand the question number 34. So here it is given, let A be 1 to n be an array storing a bit 1 or 0 at each location, which means there is an array. Suppose let's say we will take one array of index 3. So there is 0, this is first index, and this is third index, second index and third index. So this is an array, and the question says that it is storing the bit either 1 or 0, so at each location. Now there is one function f of m is a function given in the code. We don't have the function, but the time complexity of that code or that function is theta m, So let us consider the following program fragment which is given to us to solve the question. Okay, so this is the code which is given to us. Now counter is an integer which is initialized as 0. The value of counter is 0. Now there is one for loop which is starting from I equals to 0, and it will iterate up till the value is less than n, and it will, after each and every iteration, the value of I will be incremented. Now inside the for loop there is one if condition which is a of I is equals to 1, then counter will be plus, and else it will call the function which is f function, and the counter will be reset to 0. So this is the code which is given to us, and we have to find out the complexity of this program fragment. Now the program fragment iterates over the array A and increments the counter for each element, that is 1. For each element, that is 0, the function f is called and the counter is reset to 0 as given in the if condition. The time complexity of this program fragment depends on the time complexity of the function f of m, that is theta m. Since f of m is theta m, the complexity of the program fragment is also theta n. We will now let us see how it is theta n. So as the for loop iterates over the array n, and if the array is having n elements, then the loop will iterate for n times, that is the loop will take o n times. The complexity of this loop is o n. Now for each element of the array, the program fragment checks if the element is 1 here, if the element is 1 or 0, because we are storing only bits 1 or 0, that's why we need to check either the element is 1 or 0. If not 1, then it is 0. The element, this if condition will take o1 times. The complexity of this if is o1, being o1. If the element is 0, then the program, let's focus here, this is the main part. If the element is 0, the program fragment calls the function which is f of counter, and the next thing is it resets the counter integer to 0. Now calling the function, this part will take time of theta m, and the resetting counter will take o of 1. Now if we calculate the total time complexity of this program, then it will be o n plus theta of n plus o of n, which is equals to theta of n. Now How it is theta of n? Because all these on terms is dominated by the term theta n, and hence the overall time complexity of this program fragment is theta n, which is option. Now let's move to another question, number 35. The time complexity of the following C function is assume n is greater than 0. Now this is the code which is given to us, and we have to find the time complexity of this following code. Now integer recursive is a function having the parameter n, which is also integer. Now if we call this function, then it will come to the if condition, and it will check if n is equals to 1, then return 1, else it will return the recursive function which is again calling this function, plus it will again call this function. So it will be like nested calling of this function. Now let us see how to calculate the time complexity of this recursive function. So as mentioned here, the function makes two recursive calls of each input value, and each recursive calls makes two more recursive calls, and so on. So this creates a binary tree of recursive calls. Like suppose if we visualize, it will look like this is this is first ever iteration, and it will call two calls, like this first one is this call and second one is this one. These are the two calls. Then these two call will again call two different it will again generate two different calls. So likewise it will generate a binary tree. Now this creates a binary tree of recursive calls with the original function call at the root of the tree. Now the depth of the tree is n, and the number of nodes in the tree is 2 raised to n plus 1 minus 1. Each node of the tree will represent the recursive call of the function as I just mentioned. The time complexity here, the time complexity of each of the recursive call is constant. So the time complexity will be directly proportional, because the complexity of the function is constant. It will not change with the number of calls. So the so therefore the time complexity of the function, the overall time complexity of the function will be 2 raised to n. Now if we go more into the detail, the function having the two different recursive calls in the if condition, which will take O2 time, the complexity of this statement will be O2. Now each recursive calls make two more recursive calls, and so on. So it will generate a binary tree. Now the binary tree of recursive calls with the original function call at the root of the tree, which is this one. Now the depth of the tree is n. Why n? Because we have already assumed in the beginning, like the number of time, the n times the function recursive will be called. Now so the depth of the tree is n, and the number of nodes are equals to 2 raised to n plus 1 minus 1. Each node of the tree represents a recursive function call. The time complexity of each recursive call is constant, and so the time complexity of the function is proportional to the number of nodes in the tree, which is number of nodes is n. Therefore the overall time complexity of this program is 2 is theta of 2 raised to n. One thing we have to note here, if we calculate the total time complexity of this following code, then it will be O of 2 plus theta of 2 raised to n. Now, what happens here? The O of 2 term is dominated by the term theta of 2 raised to n. So now let us move towards the next question, that is question number 36. So in this question there is one recurrence equation given to us and we need to find the appropriate equation of this recurrence equation. So the t of 1 is 1, so we have one base equation, and t of n is an recursive case equation. So let us solve this question. Base equation is t of 1 equals to 1, which implies it's our base. Now t of n is 2t of n minus 1 plus n is the recursive equation. Now here one condition is given, n is less than or equals to 2. Now how to solve this kind of question? So firstly we will solve the base case, then substitute the base case solution into the recursive case to obtain a simplified recursive equation. Now how we can get the equation? As per the condition given to us, we will put value one by one in this recursive equation and create an progress and a chain of solutions, and based on the solutions we will implement like which of the following option is applicable to this case. And after solving this recursive equation we will get an simplified recursive equation, which is this one. So let's start with the first case, base case. Base case is 1, which is straightforward, directly gives us 1. Now we will put one by one value to the recursive equation. So let's start with 2, t of 2, which is equals to 2t. 2 minus 1 is 1 plus 2, which gives 2. Then less than it, that is t of 1, which is straightforward 1. Then t of 0 is t 2t of 0 minus 1, that's minus 1 plus n is 0, which gives us minus 2. Then t of minus 1 equals to 2t minus 1 minus 1 and minus 1. Is minus 1 and it will give us 2 minus 2. So we have our answers like 2, t of 2 is equals to 4, t of 1 is 1, t of 0 is minus 2, minus 1 is minus 5. Now we will check these values, implementing these values into the given options and check which of the following option is applicable for us. So let us implement in the second one, that is 2 raised to n plus 1 minus n minus 2. Let's check for 2, that is 2 raised to 3 minus 2. Now let's check for 1, then 2 raised to 1 plus 1 is 2 minus 1 minus 2. 2 raised to 2, 4 minus 1 minus 2 is 1, which is also correct. Now let's check for minus 2, and 2 raised to minus 2 plus 1 gives us minus 1, minus 2 is there, so plus 2 minus 2, so this will be cancelled, and plus it will give us 1 raised to minus 1. Sorry, I made a mistake here. Now we have to check for n is equals to 0, that is 2 raised to 0 plus 1, that is 1 minus n is 0 minus 2, that is 2 raised to 2 minus 2, it is 0. This one is not satisfied, so we cannot consider option number 1. Now let's check for 2 raised to n minus n. So first of all, for n equals to 2, 2 raised to, here for n equals to 2, we have to implement 2 in place of n, that is 2 raised to 2, 4 minus 2 gives us 2, so that one is also not satisfied. Now let's check for another option, that is C, 2 raised to n plus 1 minus 2n minus 2. So let's check for n equals to 2, 2 raised to n plus 1, that is 3 minus 2 into 2 minus 2. So it will give us 8 minus 4 minus 2, then we will get 2 is answer, but here t of 2 is 4, so not possible, so even this equation is not applicable. Now let's check for 2 raised to n plus n. Let's implement the first one, 2 raised to 2, 4 plus 2, that is 6. For 2 we are getting 6, but after solving the equation we are getting 4, that's why this option is